Zika was first isolated in a monkey in Uganda in 1947, and subsequently there were a number of cases in Africa and in Asia. But really in recent years we've seen an expansion beyond these regions. So in 2007 there was an outbreak in Yap in Micronesia in the Pacific, in which around 73% of the population were infected. A few years later in French Polynesia in late 2013 there was another large outbreak, but it was really when cases started appearing in South America that concern began to grow. The first cases in Brazil were identified around spring 2015, and there was a lot of speculation about when this virus may have been introduced to the region. One of the candidate explanations was the 2014 World Cup, which was in July 2014. And another potential candidate amongst this speculation was a canoe tournament that was in August 2014. But more recently, researchers have used genome sequences to refine this potential time of introduction. And actually, by essentially tracing out the evolutionary tree of the virus, they can identify when it was likely passed from one region to the next. And this suggests that there's evidence the introduction to Brazil was actually mid to late 2013, so actually much, much earlier than the first cases were identified. So this presents really quite a challenge in understanding this network of transmission and how it started in that region.
At the moment, 46 countries have new transmission of Zika since the outbreak in 2015. And then there are countries where it was found before, when it was sporadic transmission, some in Africa and some in Asia. Of the 46 countries, the large majority is in Pacific Islands and in Americas. But there's Cape Verde in Africa and a few countries in Asia, the Philippines and Vietnam so far. This is likely to continue. The expansion is likely to continue. Essentially, every country where the vector is present, if you introduce the virus, there will be transmission. And the vector, at the moment, we know the vector is Aedes, but not just the Aegypti. Quite a number of Aedes can transmit Zika. So certainly wherever there is dengue is at risk of Zika. It's very likely to have a big outbreak of Zika. But there are also areas where dengue is not very common, but Zika might also occur because the mosquito there, and that includes further north, Europe, south of Europe, Portugal, Greece, Italy, France, south of France, as well as in the US. And in the US, not just the south, but even quite north in the US. So there are very few places where it's unlikely, Zika is unlikely to be established. And they include the country, at the moment, as far as we know, include countries with very cold winters. For example, England. And here we're talking about transmission by mosquitoes, but transmission for sexual transmission can happen anywhere.
For many of these vector-borne infections, we see a lot of seasonality in transmission. For something like dengue fever, it typically occurs in the warmer, wetter times of the year. So for somewhere like Brazil, which between June and September is moving into the cooler months, we might expect to see a drop in transmission. This is because often things like mosquito lifespan are influenced by temperature, and obviously that will affect how long these mosquitoes are infectious for. In islands, it's often a different story. So you don't usually see this high amount of seasonality because it burns through the population very quickly. It generates what's known as a herd immunity effect. If you infect the majority of people, there's not enough susceptibles left to sustain an outbreak. So actually for dengue fever, specific viruses in the Pacific, we often see gaps of potentially about 15 years between outbreaks. And that's just because it takes about that length of time for enough people to be born to replenish this group of susceptible individuals you need to be able to sustain an outbreak. One of the big questions is how quickly Zika can reach other regions, and indeed how much of the world is potentially at risk. There's a number of tropical and subtropical areas which are similar to where the outbreaks are going on at the moment, particularly areas in Asia and Europe which potentially have similar climates. And a recent analysis used what's known as niche modelling, so trying to estimate the environmental niche that a virus like Zika has. And this suggested that potentially there's around 2.2 billion people who live in areas that could, in theory, sustain Zika transmission. I think really one of the important questions is to understand, firstly, how likely is the virus could get to these areas, and then when it arrives there, what could happen? Are there actually the sort of conditions that are needed to sustain transmission, and what could that mean for other complications?